What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-008 certification. So let's get into it. In this video, you're going to learn about general network issues pertaining to considerations for general network troubleshooting and various common issues that you are bound to come across. All right, so let's talk about some considerations for general network troubleshooting. So the list of potential issues, it grows all the time as new services and data types are provided by networks. Fortunately, there are common considerations that can help you greatly as you approach this vast and challenging topic. And here are some common considerations and best practices that you should keep in mind. So the first one we're going to talk about is called device configuration. So you should be consistently reviewing the configurations of network devices to ensure that your network is not suffering from what is called configuration drift, which is configurations that gradually change from their original documented defaults for a network. Many software packages and tools, such as Ansible, they can assist you in making sure all your network devices remain in a constant, stable, and known configuration state. All right, next we have routing tables. So it is important to carefully monitor and analyze the routing tables of layer 3 devices. Forwarding decisions are critical to the operation of a network, and you want to ensure that packets are flowing exactly as you want and expect them to. All right, next issue we have is interface statuses. So one embarrassing network issue that you do not want to experience is the administratively down interface scenario. So in this scenario, you try to desperately reach a key network device only to discover that you failed to enable the interface that you are trying to contact. Remember that there are simple commands you can use and even GUI-based web pages that give you status information on your critical network interfaces. And knowing which are healthy and which are not can be critical in network troubleshooting. And as a side note, often the status of an interface in a network is contingent on the network layer settings. The physical and data link layer settings might be fine. That is, the Cisco displays the status as up. But if the IP settings are incorrect, the physical and data link layer health of the interfaces are not of great benefit to you. In the following settings, they typically have to be perfect. That is the default gateway IP address, the subnet mask, the IP address, and the DNS address. Now, think about the symptoms you might see for each of these potential misconfigurations. So for example, if your default gateway IP address is incorrect, you might be able to communicate with your local subnet peers just fine, but you will not be able to successfully reach any remote destinations, which ultimately would not be a good thing. Right, next, we have the VLAN assignment. So ensuring that the right interfaces are in the correct VLANs is very important. Now, remember that VLANs are IP subnets, so it makes perfect sense that if you have two machines in the same network, these machines must be in the same VLAN to properly communicate with one another. And next, we have network performance baselines. Now, as you have probably noticed throughout this course, it is critical that you know the details about how your network performs under quote unquote normal conditions and what its speeds and throughput really are. Now, how can you know that you are having a problem if you don't even know what your network should be performing like when there are no problems? Fortunately, as this course has discussed, there are many tools and techniques for capturing accurate and detailed network performance baselines and using the data you collect to keep tabs on the network. Next, let's talk about some common issues. So the following list of common general network issues may be a bit intimidating, and it is not even an exhaustive list. As a network administrator, and as a candidate for the Network Plus certification, you need to understand the following common issues. So the first one is the duplicate IP address. So hosts on the subnet should have unique IP addresses. If two hosts are configured with the same IP address, unpredictable traffic patterns can occur for those hosts. And one reason out of many that this might happen is because a DHCP server is inadvertently leasing out an address that has been statically assigned on the network. And these statically assigned addresses should be excluded from the DHCP scope. Next issue you might experience are duplicate MAC addresses. So although it's rare than a duplicate IP address on a network, a MAC address can be duplicated. A MAC address on a network is typically taken from the address that is burned in to the hardware by the device vendor. To ensure uniqueness between vendors, each network device vendor is assigned a MAC prefix, and the vendor can control the remaining bits. So therefore, when a MAC address is duplicated on a network, it is most often a human error that occurs when MAC addresses are software defined to override the hardware addresses that are burned in. All right, next issue is expired IP addresses. So perhaps a leased DHCP address has expired for a workstation. This might be the case, for example, if the lease duration has been set to a small value, perhaps because of an IP address shortage in a particular area of the network. Then we have DHCP scope exhaustion. So if your end user network device population has grown, you might have issues with DHCP scope exhaustion that are innocent in nature. In DHCP scope exhaustion, this refers to the scope being completely out of IP addresses that it can lease to clients. If your population is outgrowing your design, a redesign is expected, and you should not be surprised by this. DHCP scope exhaustion attacks can be very disruptive because you will not know it's coming. Suddenly, clients in your network cannot communicate properly as they have lost their IP address configuration. Next, you got what is called a rogue DHCP server. So this security concern could certainly cause troubleshooting headaches on the network due to the incorrect IP configurations that could result. When rogue DHCP servers appear on the network, it is often because users have brought in their own devices, either maliciously or accidentally. Next, we have what is called an untrusted SSL certificate. So if you're using certificates for authentication, you might have an issue with an SSL certificate preventing such authentication. Perhaps a certificate is invalid due to time, or perhaps it has been manually revoked for some reason. Next issue you might experience is incorrect time. So because many network configurations rely on the correct time, you might have problems in the network due to a workstation server or network appliance having the wrong time set. Remember that you should strongly consider using network time protocol or a competing technology to help ensure that your network devices are all set to the correct time. Another issue you might experience is blocked TCP and UDP ports, services, or addresses. So a trouble ticket may be about blocked TCP or UDP ports, and this type of blockage is often the result of misconfigured security devices in the network path. There may be other security mechanisms that are blocking specific IP addresses or services, and these are all worthy of inspection when you are experiencing unexpected connectivity issues in a network. Another issue is incorrect firewall settings. So host-based firewall settings and network-based firewall settings may cause problems. Firewalls are great, but you need to make sure they are not blocking traffic that you need to pass through the network. Then we have incorrect access control list settings. So ACLs can have effects on network traffic, and if their settings are incorrect, you could end up with a bunch of trouble tickets. We have unresponsive services, and these are services that have failed in a network, and they could be a common source of problems. Next issue you might encounter are collisions. So you should not see any collisions taking place if you have built a network using modern techniques and standards. Remember that micro-segmentation of a network means keeping single devices in collision domains so that you do not experience collisions on the network. Often, if you are seeing collisions on the network, it is an indicator that you have a misconfiguration or a hardware device that is malfunctioning. Next, you might experience broadcast storms. So this might sound crazy, but it is possible to go to a layer 2 switch and turn off the spanning tree protocol. However, this is never recommended, even in cases when you don't need STP because you have used technologies like port channels. You need to make sure STP is still enabled and running in the background. If STP isn't running, a broadcast storm may occur as a result of a layer 2 loop. You might experience broadcast storms for other reasons as well, such as a NIC that's malfunctioning and flooding the network with erroneous broadcast frames. All right, next you might experience multicast flooding. So you need to be concerned about broadcast, unknown unicast, and multicast traffic, which is also known as bum traffic on your network. And this is the traffic that layer 2 switches must flood. You want to minimize the amount of traffic flooding your network must perform, and you therefore often need to closely analyze the amount of bum traffic flooding. In addition, you can use protection mechanisms such as network storm control to guard against excessive amounts of bum traffic hampering network operations. Another issue is called asymmetrical routing. So sometimes packets take very different paths to you than they took towards the destination. This situation called asymmetrical routing is not always a bad thing. Sometimes you even engineer it to happen for specific reasons. Often, however, Asymmetrical routing is not wanted and can likely lead to issues. Then we have what are called switching loops. So if STP is not running correctly or it's not running at all, it will not be long before you have broadcast storms and switching loops. These are the enemies that STP is engineered to protect you from. Then we have what are called routing loops. So the dynamic routing protocols in use today, they do an excellent job of protecting themselves against loops. In fact, a loop could never get terribly bad because of the time to live mechanism at layer 3, which prevents a packet from circulating on the network endlessly in a loop. And layer 3 can still happen though, especially when redistribution between routing protocols is configured incorrectly and they are still awful. So be very careful when performing redistribution. Another issue you might experience is missing routes. So when a user indicates that a remote destination must be down, be sure to run through your methodical troubleshooting steps. In many cases, you may discover that the issue is simply a missing route in the local routing table. And remember that networks change. You need to ensure that your dynamic routing protocols or even static routes are being updated properly. Then you might experience a hardware failure. So network devices or parts, they can sometimes fail and components can burn out. Such failures are rare, but you need to consider them in your troubleshooting flow. Then we have what is called a low optical link budget. So a fiber optic link budget, which is also known as a loss budget. This indicates the total acceptable amount of optical power loss, which is expressed in decibels, that a fiber optic link can withstand. In such power loss, this results from cables, connectors, splices, and couplers that are installed in the system. Next issue you might encounter are BYOD challenges. So perhaps the investigation of a trouble ticket reveals that an end user is trying to interact with your network by using a tablet he or she brought in from home. Whether or not your BYOD policy allows this type of use, and how you control this potential nightmare, such as through a mobile device management policy, this is an area of networking that deserves your attention. Then we have license feature issues. So sometimes a network does not function properly because the organization lacks the appropriate licensing. And licensing of network devices can get quite complicated. So you might need a license for a network device itself, and then you might also need additional licenses for certain features or levels of scalability. And then finally, we have network performance issues. So sometimes you know exactly why a network is not performing well. So for example, you might have to fail over to another service provider in a very slow backup wide area network link when the main service provider is down for maintenance. It is always an excellent idea to inform end users about these kinds of issues up front to prevent the disruption that will be caused by a flood of trouble tickets. All right, so that was my video where we talked about general network issues pertaining to considerations for general network troubleshooting and various common issues.